Hi guys, so let's proceed with chapter 4 functions. The first subtopic 4.1 relations and functions. So what is a relation? A relation is a correspondence between a first set called the domain, second set called the range, such that each member of the domain corresponds to at least one member of the range. Okay, by looking at the type of relations here, so what does it mean by the definition saying that the first set called the domain? This is the first set, guys. So we call it as input, and we can call it as domain, we can call it as object, we can call it as x values or elements of x. So this is the opposite one, the second set, stated as output, but still we can call this one as range, and we can call it as image, we can call it as y values or elements of y. Okay, so moving on to the type of relations. So I think you knew already why this one we call it as one-to-one. Obviously, by looking at the lines, many to one. Take a look at the input or the domain here. -2 and 2 both map to 4, a single y. That's why we call it as many to one, one to many relation. Take a look at this part here. X element here is -2 moving to both 1 and 3 as the y values. So a single x moving on to two values of y, that's why we call it as one to many. And then obviously for this one, many to many relations, you can conclude by yourself what does it mean by many to many relations. So function, what is the definition of function? A function is a mathematical rule that for each input x, there is one and only one output y. So that's the keyword. So every x must have a single y. So take a look back at the diagram above. By looking at the output one-to-one relation here, every single x map to a single y. Second diagram here. Every single x map to a single y. Even by looking at the green color, alright? So even -2 to 2, these two sharing the similar image or output, that is 4, still it is a single value of y. So many to one, one to one, these two relations are a functions. Alright, so take a look at one to many and many to many. One to many, -2 map to 1 and 3. As I told you before, the function, the keyword of function, we need each x map to a single y only. So that's why this one to many relation is not a function. So many to many, of course, many to many is not a function. Why? Because obviously we want each x, each input here to have a single y only. Therefore, many to many is totally not a function. Okay, let me help you on to remember this. A function has a domain and a range. Okay, just remember the word docs, D-O-X. D, domain, O, object for X values. So the opposite one is going to be for Y. What does it mean? Range, image for Y. We can determine the function by looking at the relation just now. And actually, we can determine a function by using the graph, a graphical method. We can use vertical line test. If a vertical line test can be drawn anywhere on the graph that it touched 2 points, then the graph is not a function. It's okay, I will clarify this one later in our tutorial. Okay, so let's talk about onto function. A function, we can call it as onto function if every y there is an x. So that's the keyword. Every y there is an x. So take a look at the diagram. Recall it back. This one is one to one. relation. This is one-to-one relation as well, but this one is actually many to one. That's why the statement given to you here is not one-to-one, because this is many to one. So focus on onto function. What does it mean? Every y there is an x. So take a look at y value here. All y values have an arrow, right? So this is onto function. Easy. So take a look at this one. Not every y have an arrow, because this 4 doesn't have any arrow. So this is not onto function. This one, take a look at y values. Once again, all y values have an arrow at least. So we call this one as onto function. And then there is extra statement here. Therefore, the range equals the codomain. So what does it mean actually? If the range is similar to codomain, so that is onto function. Alright, so what is range? Range is 2, 3, 4 in this case. But in this case, the range is -1 and 3. Okay. What is codomain? Codomain in this case is 2, 3, 4, similar to the range just now. So once similar, that's why we call it as onto function. Recall it back. The range of this one is -1, 3. But the codomain is all the elements which are -1, 3, 4. So that's why the range and codomain are not similar. So this is not onto function. And the last diagram, range and codomain similar. That's why onto function. Alright guys, so let's talk about concepts of relations and how do we represent the relations. Actually, we can represent it in the form of table, graph, and mapping diagram. So take a look at the question given to you. Express the relation for the track meet scoring system 1, 5, 2, 3, 3, 2, 4, 1 as a table, as a graph, and as a mapping diagram. Okay guys, so take a look at this one. This is x, this is y, this is x, this is y, and so on. Okay, the x values are 1, 2, 3, 4. That's why 1, 2, 3, 4 in table form. Okay, the left part here always the x values, the right part here always the corresponding y values. As we can see that 1, 5 actually represent this coordinate 1, 5, and so on 2, 3, 3, 2, and 4, 1. Okay, so this is table form. Of course, we can convert it into graphical form. So by looking at this graph, take a look at the points here. This point actually represent the coordinate of 1, 5, 1, 5. So this one, and then the next one is 2, 3. The next one is 3, 2, and the last point representing 4, 1 as the question given to you. And please remember that our horizontal part is the x values. Alright, so vertical part is going to be for y values. And then actually once you have table, easily you can convert to mapping diagram. Take a look at the value here, 1, 2, 3, 4, 5, 3, 2, 1. So 1, 2, 3, 4, and then 5, 3, 2, 1 for the y values. Alright, so this one, simply make a shape like this, both parts here, and then simply draw a line. Make sure you will put an arrow here, okay, showing that this one map to 5. Okay, that's it. This is how you're going to represent a relation in the form of mapping diagram. And then the last part is domain and range. I think it's quite complicated. Okay, let's make it easy. What is domain? I told you just now, docs, domain object for x. So what is definition of domain? Domain is a possible x values for a certain function. Range is a possible y values for a certain function. Okay, that's it. Done already with the notes of 4.1. So let's try our best to answer the question.